Okay. Sure, Lakshmi. Can say that. Could you please give me an example of parent and child task in real-time scenario? Okay. So suppose, so when you are implementing data loads, so first there will be a dependency. So first, so you have to load the data into dimension tables. Then we have to load the data into fact tables. Dimension tables. Then we have to load it into fact tables. Then, so without loading the dimension, fact tables load should not happen. This is a dependency. This is one kind of dependency. Or another thing, we have a table. Okay. Based on table, once the table data is updated, once the table data is updated, then only so you need to so refresh or you need to create a view. You need to create view. Just a minute. The view concept we will discuss in the next thing. View. Okay. It can be a so normal view, or it can be a secured view, or it can be a metless view. In this situation also, we will use the dependency. Okay, it depends on just a business scenario. So before doing that, so we have to cross check so other things have happened or not. Okay, fine. Is it clear, Lakshmi? Just a minute. I am not sharing my screen. Okay, so dimension tables and then fact tables. So the fact tables load dependence on dimension tables. When you are creating a view, the table should have a data. So without that, so if you create a view, there is no use. So after always, so the data has been loaded into the table first, then we can able to create a view on the table. So this is the dependency. Okay. Suppose, so when you have any failures, so suppose when you are using a copy command, after copy command executed, then only we will use valid option, right? So once we copy command executed, then we are implementing what all the errors we have in this copy command by using valid option. This is kind of dependencies we can use. Okay, it's clear.
Sir,
Yes,
um, while we are running the child task, it's like a iteration. Means the loop is running again and again.
exactly.
If it is, mm, then the child task is
Mm,
repeatedly running. No.
correct. Repeatedly it will run. Whenever, suppose, copy command when it will run. Copy command will run when you have a data, right? This we will see that in a this one continuous ingestion process. So whenever this completed, every time the copy command runs, the validate option you have to check. You have to check for the errors. Every time you have to
Uh,
do the same thing.
no, I'm saying that
Mm,
suppose if the child task, parent task run for one time,
mm,
then the child task run for one time. So the
correct.
values are 1, 1.
Mm,
Okay. Again, if you suspend it, and
mm,
again
resume.
will resume.
Mm,
Okay. Then the parent task values are 1, 2, and the child values are like 1, 1, 2.
okay. Mm, correct.
Then
Mm,
the child task is having the copy
mm,
of previous values and the present
correct.
values.
True.
So is
Mm,
it like that, or
no,
so
no,
in the
that is
dimension tables?
I will tell you. I will tell you. So don't get confused here. So why the values are copied multiple times is here. Observe this one. So when you are implemented a child task, what is the condition we have given here? So maybe you get confused with this. Every time. we are loading the complete data. This is just for your example, just for, so like I explain the example, I have given this. It will not happen every time. It is copying all the data every time from the same table. That's why every run, it will pick all the data and then it will load all the data to the child table. But generally it will not happen, right? You are going to pick only based on max timestamp or maximum records or any new records only. You will not pick all the records every time. Is it clear? Here you got confused. Insert into the child table. This is the child table. We are selecting all the records from, so your parent table. Every time when it is running, suppose let's come here. Every time, so when this statement is running, what this statement is doing, in employee table, how many records is there? All the records we are inserting into this table. Suppose let's assume that in this parent table, first time we have one record. Okay. Second time we have record 1 comma 2. In the third time 1 comma 2 comma 3. First time the child table will run, right? How many records it will be there? One record. One record. Next time what this is doing, again it is copying all the records. Already in a child table you have one record. Again it will copy the complete data 1 comma 2. Next time already you have 1 1 comma 2. Again what it will do next time, again it will copy the complete data every time. So that's why, so you are getting, so the same multiple records into your parent table when you are executing this one, when you are executing this particular task. Is it clear now, Lakshmi? If you are speaking, I'm unable to hear anything. Okay, still if you are not clear, please so call me or you can text me in WhatsApp. Okay, so we'll connect and I will explain. Okay, thank you. So now let's come to our topic. Let's come to this. In the last session, what we have done, we discussed about so data masking and then pricing model, right? So how to create a,
Sir, can you please
sorry,
share your screen?
just a minute. It's clear right now. Now you can able to view my screen. Okay, fine. So what we have done in the last session, we discussed about so pricing model and then a resource monitoring, right? How to, so what is the pricing model, how it will differ, so and then how to create a resource monitoring, so based on our so pricing model. Okay, so now in this session what we will do is we are going to discuss about so how partitions will work. Partitioning will work generally in any traditional databases. What we will do, we will create partitions. We will create partitions and we will create indexes and we will create hints and we will try to improve the performance So whenever it is having huge volume of the data, right? Now let's observe this. Suppose in this particular table, line item table, how many records we have? Some billions of records we have. And what is the size? 159 GB. And means or almost it's a 160 GB of the data. 160 of the data we have here. Okay. So when you check this particular table, observe this what I am doing. Select star from this particular table, and we are going to use where condition, where based on so ship date. So what is the cluster by column? L ship date, right? So let me see first 100 records. We can go for this one. Ship date equal to, I will pick any one specific date here. This is the date. Okay. Now, if you run this particular data without any condition, it will take so minimum so 20 to 30 minutes. Now, or about that also. Now, when you are running this with this particular condition, so with the so where ship date equal to this one. Now observe this. How much time it has taken? 5.92 seconds. How fast it is, right? So in this, these many records it picked. So within, so what is the time? 5.29 seconds. Observe this one, 5.29 seconds. So because before this, so 5.29 second, it displayed the data. What happened in the backend? If you observe, its around size is 160 GB, and then billions of records we have. So if you see this, so what happened in the backend? Come to profile view. Profile view means nothing but query explain plan. Query explain plan. So when you observe this query ID, this is the query ID. Click on that and then come to the profile. Come to the profile and then observe this. What you can able to see here, you can able to see the result filters, most expensive nodes, right? Most expensive nodes. Here you can able to see where it has taken more time, right? And then so what is the table scan? Now when you observe one thing, see this one here, what you observe this one, partition scanned. Partition scanned. So what it is telling, partition scanned 6, sorry, so total partition scanned 6. How many number of partitions it is available? 10,336. These many number of partitions, it didn't went to each and every partition, and it picked only 6 partitions only. It picked only 6 partition. But so how the, so this one will understand, the Snowflake will understand exactly it has to go to this only, these 6 partitions only. This is based on your partitions, how the data is partitioning in your Snowflake. The Snowflake partition, we used to call it as a micro partition. This technique we will call it as a pruning. See this one here, pruning option is there, right? This particular technique we will call it as a pruning. Now let's come to this and let's observe what are the things we can able to do it here. So partitions, let me go to this. partitions. Now observe this one. What Snowflake will do is, whatever the data we have, it is going to create in micro partitions. There is a size of micro partition we will discuss. Now if you observe the data, how it looks like here. See this one, how it looks like the data. This is generally when you select star from table, this is the data. When in the back end, when it is storing, we cannot able to see this, and we cannot able to create any partitions as a user. All these things will be taken care by Snowflake only. This is complete considering as a software as a service. So we will not have any other option. So to create a partitions, to create partitions. Now let's observe this one. This is a table, right? This is a table. Now in this table, what it will do is, it will create partitions, and this is columnar storage. Columnar storage, what it mean by that? Now when you observe, each and every column, it is storing in the form of rows. See this one. First we have a column. What is the first column? Type. This column, when it is storing in the backend, in the storage, see this one. So type first 6 records in micro partition 1, next 6 records in micro partition 2. So next 6 records 3, next last 6 records in micro partition 4. It's divided. It's divided into 4 partitions based on, so what the data available in your table, and each and every column, it is distributed into all the partitions, right? This is columnar storage. Columnar storage. Now again, so next column, name. Again, the first 6 records it is storing in micro partition 1. Next 6 records it will store it in another partition. Like this, it is going to so create a partitions. These partitions is nothing but in the form of file formats, compressed file formats, compressed data and file formats. So when you run any specific things, suppose, see this one, so type 4, and then name C, and then country, so this one SP, and then date, this particular date. We need to pick that information from here. We need to pick that information from here. So when you are picking this information from here, so what it will do is, first it will go and then check in micro partitions in storage, which partition the requested data is available. In which partition the requested data is available? In partition 1. Then directly it will pick that partition instead of scanning the complete table. If you have, so in this example, if you see, you have all the 10,000 partitions. If it wants to scan each and every partition, how much time it is going to take, right? So but, so how many partitions it scanned? Only 6 partitions. Now when you come to this one, so how it happened? This based on micro partitions, whatever the micro partitions the Snowflake is created. Again, what it will do is, in the back end, it will have metadata. Okay, before that, observe this. This is the columnar storage, guys. How the storage will happen in the back end. So this one, this is a row storage, columns and then rows. But this is columnar storage. Now each and every column data, it will be stored like this. So this type, name, country, and then date. Okay, so file header it will be so like this. So now let's come to this. So how the day, so what it contains for each and every micro partition. Each micro partition, again, it will have this metadata information. It will have the metadata information. So when it is having the metadata information, now observe this. So these things, so for ID, what it will do? Minimum to maximum, it will give the values. For So so channel. So again, so minimum to max, like in ascending form. And then values. Observe this one, range of values in between 150 to 900. The month Jan to Feb. Here we have in the partition one. What micro partition? So metadata is doing. This is a micro partition. How it is storing in the storage layer. This particular storage information, it will be in a cloud services layer. Based on this, first when you execute a query, first it will go to the cloud services metadata, right? There it will decide which partition I have to pick for this requested data in storage layer. So that's how so it is going to work exactly. Clear. So now, so let's come to this one. So each and every micro partition. So this is the example, another example for metadata. Each and every micro partition. This is the interview question also. Each and every micro partition, 50 to 500 MB uncompressed data, uncompressed data, and it will be maximum 16 MB after compression. After this is after compression. Before compression, 50 to 500 MB. Is it clear? Okay. And each and every partition when it is created, it is immutable. It means you cannot able to so change, you cannot able to update, you cannot able to delete any partition once it is created. Once it is created. Now let's observe this, what it mean by that. So this is partition, so pruning method, we will come to that. So now this one, this is the example we saw that. But how the partitions will be created automatically. So what is the mechanism it is going to use in the backend? And again I am telling, as a user, you will not have any rights to create. Everything be done by the Snowflake itself. In the backend, they have some algorithms it will run. Based on that, it is going to create. We will go to that. Before that, what we discussed, these micro partitions are immutable. What it mean by that? Now, let's observe this one. Here, for example, we have a data micro partitions in Snowflake. How the micro partitions improve the performance. This one discussed. Now let's observe this. When you have the data, let's assume this is the data, 6 records divided into 2 partitions, partition 1, partition 2. This is done. Data is loaded. Now it is having 2 partitions. Assume that, so maybe next load, what it is doing is, so we are going to so delete or insert. So this one we are inserting one record called Steve, right? We are inserting one record. Already partition 1, partition 2 created. When we are inserting another record, what will happen is, see this one, it will create a new partition called P3. It will create new partition called P3. It will not go and then update in any P1 or P2. It is not like that. It will create a new partition. Okay. Now next, come to delete. So when you come to the delete option, suppose, so in, so the particular thing, the and use, this particular person is deleting. So from here, from P1, right? P1 we are trying to delete. When you are trying to delete, so now observe this one. So what will happen? See this, it's deleted and it inserted new partition. Complete file, it will be removed. On place of the complete file, it is going to insert the new file. See this, P1 is gone. P1 is the older version, and then P4 will be there. P4, it will be created. Now see this. Again, if you do any other so option, suppose so from this here you have updated something, then what will happen is, instead of P2, so you will get after already P1 to P3, P4 is there. Now it will be created P5 partition, means whatever the partitions it has created, so there it will, so not attach, it will replace that partition with new partition. See this one. So with the changes, new partition will be created in that place. So previous partition will be maintained in the backend for the, so versioning purpose. Okay, this is how. So when you are inserting, when you are deleting the data, partitions will be created. Okay, this is clear. Now let's come to this one. Say, okay, so what is the mechanism it will run in the backend? That particular thing, clustering mechanism. Clustering will happen in the backend. Now observe this. What it will do is, clustering is different. Okay, clustered is different. Okay, let me show you something here. What it will do. Now observe this one. Clustering by default it will take based on all the data. Cluster by is based on specific columns. If you observe the data here, have you done anything so to create these things? No, it has created automatically because it's a shared data. Let it be. But one more thing, if you observe here, every table is not having cluster by. See this one, cluster by. Here we have, here we don't have. Here we have cluster by. Here we don't have, right? So here, so we have, here we don't have, here we have, right? It is not required to create cluster by option for every table. So what is in your hand to improve the performance in Snowflake? If anyone asks, you can do cluster by column on a table. That's it. Other than that, you will not have any option here. Okay, so that is fine. So before that, let's understand. We will come to that. Before that, let's understand what it will do in the backend. The Snowflake, what it will do, how it will create a partitions. See this one. What it will do is, when the data arrives into the table, it will wake up. Okay, and internally it will split all the tables, so files, into the levels. That is clustering state, level of, so splitting is clustering state. When it will run clustering partition algorithm on each level, I will show you what it meant by level. Each level it will run, and it will queue up recluster task for execution. So when it will queue up, see this one. So scale up and execute recluster task, and size just not right. Size is not right. It optimize, so not to, so spill. So and so non-blocking, mistake, commit. If it is non-blocking, then it will commit. So then if it is size is not right, then again what it will do is, again it will retain the clustering. See this one, if the clustering depth is not good enough, it will repeat this particular process in the backend. Automatically it will create a, so cluster, and then it will keep on running until the size is good enough, clustering depth is good enough. What it mean by clustering depth here? Now if you observe, this is the clustering depth. See this one, the levels will be there. First level, second level. Let me show you. This is clustering depth. See this one. Reducing clustering width with the levels. See this. The first level, this is the clustering levels. Now, if you observe in zero level, you have all the levels, it will be clumsy, right? So all the things, it is very clumsy here. Now, when it is coming to next level, see this one, somewhat little better. It is occupying this place, and level 2, and then level 3. See this one, in level 3 individually it has created each and every, so cluster, right? And see this one, more partitions with shorter range of data. So what it will do is, So it will keep on doing the clustering until the clustering depth is good enough. Good enough means clustering depth. Observe this one. Initially, it will start. This is clustering depth or overlap depth. So this one is 1 here. This one is 1. Overlapping micro partitions is 0. So when you observe the black line in the back end, what it will do is first it will create the partitions like this. Let's assume that we have records from A to Z. It will divide that A to Z records. So like this. Okay. See this one A to D, E to Z, K to N, and then O to S, T to Z. All these partitions, micro partitions, it available in the one this particular place. Okay, space it has been occupied. So when this is not good depth level, then what it will do, it will identify. So overlap depth is 5. So then again it will come and then it will divide the data. It will distribute this partition to the different places. See this one, other occupation 3. Again it distributed. So now it is 2. Again it's distributed. Again it is 1. Now what is the overlap depth? 1. It means in a single partition, so other data is not available. So up to this level, it will try to create a partitions, that is overlap depth. If you observe here one example, I'll show you another example. Just a minute. This one. Yeah. Now observe this one thing. Now we have some values. Partition 1, so we have 0 to 26. In partition 2, 20 to 60. Partition 3, 50 to 75. Now when you observe this here, see this overlapping means nothing but here we have 0 to 26 in partition 1. Here we have 22 to 60, right? It means 20 to 26, 6 records. It is available in partition 2. It is available in partition 1. Again, when you come to this, here partition to 20 to 60. Here 50 to 75. Then if you observe one more time, so here 50 to 60 is available here. Same 50 to 60 is available here, right? So this is overlap depth. This is same records available in both the partitions. What Snowflake will do, it will reduce this particular overlap depth until this particular level. So it is, you saw that, right? Come to this until, so this particular clustering level until it goes to clustering depth 1. So now there is a no overlap. In the backend, it will take care how it will do. It will run a backend algorithm. Some algorithm it will run, and then it is going to implement all these things. This is in the backend storage. Now, what you can do to improve performance, only one thing, that is you can create cluster by key. Cluster by key. You can able to do it for the combination. What is clustering means? Observe this. It is going to store in the table sorted order along with natural so dimensions the data, right? And see this one. So clustering is a key vector inquiries when you are sort the data, so faster retrieval. Just we will use it for to once it is sorted the data, it will be so retrieval will be fast. It is nothing but in traditional database we used to sort the data in ascending or descending order, right? The same thing we are going to define. So based on specific column, that is nothing but cluster by. We will see this one with example. Now, so when you have a table, so it is not sorted or partially sorted, it will impact on the query performance. This is only for large volume of the tables, huge volume of the tables. We cannot implement this cluster for every table. It is not possible. Okay. So when the data is insert and loaded, once you create a cluster key, see this clustering metadata is collected and recorded for each micro partition. It will be so recorded, so and then collected for each micro partition. Okay. So using so this clustering information, the Snowflake avoids, see this one, unnecessary scanning of the data, unnecessary scanning of micro partition during so querying, which significantly the improvements performance. So that's why if you observe this clustering, based on this clustering key information, so it is going to so pick very faster. That's why observe the key which we have given in the where condition. If you observe this line item, we have a clustered by ship date, right? We have a clustered by ship date. That's why when you want to pick some information from any huge volume of the table, just check, do you have any clustering column, cluster by column on that particular table? If you have, use that cluster by column in a where condition. You can use that in a where condition, then it is going to display so all the records related to that particular thing. It will be very fast when you implement based on cluster by. That is one thing. Okay. Now every table we cannot implement cluster defaultly. That is not suggestible. This is another interview question. So every table we won't give the cluster blindly. That's why if you observe, only some of the tables we have cluster, and then other tables we don't have cluster. See this one, each and every table, observe cluster by, we have some columns, and then cluster by we don't have. And one more thing, it is so not like that. You have to create only one cluster. See this one in this table. So one cluster, in this table, one cluster. Here, how many clusters we have? We have two columns. Based on two columns we have, it means they are going to sort the data in the table based on these two columns. Okay, now let's come to this one. So let's say for example, so this is fine. So when you observe, so another tables, so we don't have so any other some of the tables, so most of the tables here, some of the tables we will not have the cluster. In this schema we have most of the things cluster. In this schema we don't have for the each and every table. It is not mandatory to create cluster for each and every table. Okay, when you are going to define a cluster, so in which situations, so this one, use only for very large tables, use only for very large tables. So it will be so in more than like 2 terabyte or 3 terabyte is available, then only you will implement cluster by. Okay, when it is increasing performance, why we should not use? You can use, but the thing is, when you are using cluster by, Snowflake will charge for the cluster by option. Some amount it will be charged. Okay, so that is the main reason we will not improve the cluster by for everything. So it will improve so scan efficiency, and no additional administration is required. It means once it is created, automatically it will take care from the backend. No need to do anything. Okay, and then see this future maintenance also performed automatically by Snowflake. Because of these two things, Snowflake will charge from the users. Okay, and when to use a clustering key? Observe this. Queries on the table are running slower than expected. Suppose today we ran a query, maybe tomorrow we ran another query. Every time when you are running some queries from the table, it is taking every time it is increasing the time. Then so only you have to implement a clustering key. And clustering depth for the table is very large. See this one. If the so depth is very large, then what it has to do? It has to so split it, and it has to so make sure that clustering depth is one. Okay. And Let's come to this one. How to create a clustering key. How to create cluster by option here. Now, when you come to this, it's very simple. So we will not use this. For to implement this, we will have some multiple levels of permission, because again the Snowflake will charge from the users. Now observe this. How to create the cluster by create or replace table. We have two columns, C1 and C2, C3, and then cluster by. Observe this. When you are creating a table, generally what you are doing, we will run this one. Create or replace table name, C1, and then C2 column names, and then we have a data, right? Cluster by we have a data. When you have this, so cluster by we are telling C1 and C2. So this is the extra thing what you need to implement when you are creating a table. Now observe this one. Let's run this. Okay. Insufficient privileges because we are in a developer role. Let's come to this account admin. Every role will not have a option to create cluster by account admin. Now observe this one. Created, right? Table created, where we created class and public schema. Now let's observe this. Come to that one. Refresh. Come to the class. Come to the public schema. Now come to the table which we created. T1. Observe the cluster by C1 and C2. So like this was based on combination we can able to create a cluster by. Another thing is, so we can create, so for strings also, it means we can able to distribute and then we can able to do that. Now let's come to this one. For example, show tables, it will give you on which column you have a cluster by. See this what we are doing, we have three columns here. Create or replace table, T2, cluster by, so we have date column, so we have a string column. In string, so this particular one, C2, what you need is, we need to create cluster by only for the specific values, C2, 0, 10. Okay. It means, let's assume that when you have a data in a column, so first, so the data is like this. Okay. Let's say, for example, we have a SSI number. Okay. Some identification number. After that, we have full name. After that, we have it's assigned with the full name. So first, so identification number, after that full name is there. Then you need to sort the data only based on this SSI number. Okay. So identification number. So we don't want to sort on the complete column. That option is available. So for that, we have to use substring function. Observe this one. Create or replace table name. So see these are the columns. So cluster by, see this one clustered by. So this is the date, and then so we have a, so the substring of, see this one column. So 0 to 1. What you are telling? 0 to 1. 0 to 1. So now when you run this, it will create a cluster. Now observe this one based on that column. So if you observe show tables, it will give you the information related to the cluster by. So or you can able to see it here also. Here you can see T2. See this one? You can able to see the cluster by. And if you observe show tables, here it is telling, see this cluster by option, linear, right? And then we have two clusters, right? And then automatic clustering is on. It means when you have, once you created a cluster, and this one is telling that linear, don't get confused here. This is the algorithm, it will run in the back end for the to create a clustering. Okay. So and when it is inserting the data, once you created a cluster by, suppose when the data is inserting, or when the data is updating for any specific table. Based on this cluster, it will order the data and then it will store it in micro partition. The ordering of the data when it is maintaining micro partition metadata, right? It will consider that cluster by column. Let me show you something. Here we have micro partitions. When it's created, let's come to that micro partition metadata where it is. Yeah, here observe this one. In micro partition metadata, what are the columns we have? ID, channel, city, value, and then some other month, right? When you create a cluster by column on any specific columns in micro partition metadata, it is going to pick that information and it is going to create. So based on that particular specific column, on which column you have created a micro party, sorry, we created a cluster. So base that particular column will be available in this metadata information also. So when it is fetching, it will be easy for Snowflake. So in which metadata that particular related data is available, right? So based on that, it is going to so perform the so task there. Okay. So now, so let's so observe this. So same thing. So here, right? Same thing here. But so generally, most of the time, so it will not, so we will not able to, so we will not implement this cluster by for every table. It is not required. And one more thing is partition also. When you are implementing partition, so as a Snowflake user, so for us, you will not have any rates, but you need to understand so how the things will work in a backend. This is very important because in some interviews they will ask how the storage will work, how the Snowflake is very fast when compared to the so other databases. What is the mechanism in the backend when it is automatically creating a partitions? So these things we have to understand. Okay, that's why we discuss these so high level concepts. So next what we will do is we will work with, we'll see how to work with the AWS. Okay, and then if you have a file in AWS S3 location, cloud location, how to pick, how to load the data, we will see that in the so next session. Okay, it will take some time. So any questions here, guys? Any specific questions?
Sir, you said that
Mm,
usually the clustering,
mm,
uh, like we have to take the permission of that the
mm.
Snowflake people, and
No, no.
that is how
So,
they will do this,
mm, mm, mm.
right? But
Cluster by, if you want to implement, we can able to create like this. But before doing the clustering, so we need to take the permission from, not from the Snowflake support team, so we need to take the permission from so our higher level. So it means nothing but
oh,
so our architect or your so lead, so who is working on, who is like taking care of the storage and all those things, and then who is taking care of the billing, because it is directly related to the billing. When you implement a cluster, your additional the billing will be charged for the cluster. First you need to observe, when if I create a cluster by on this particular table, how many number of users is using this particular table, and then what is the purpose, how frequently you will use this particular table. Based on that, they will decide and then they will let us know, yes, you can go ahead and create a cluster. So that is the thing.
yeah, you said that like
Mm,
when the
mm.
performance is degrading, right, over a
Correct,
period of
exactly.
time.
Mm,
So, but
mm,
you said that you had to create the cluster by
mm,
during the table creation, right? So
mm,
how will you know that the performance, like when the
mm.
performance is degrading, then only we need the cluster by. So, but
Correct.
already we created the table, right?
No, no.
Without
Here
using
in,
that option.
yes, yes. For example, initially we created here, we can able to alter the cluster also. Once the table, let's assume that the table is created, then
Okay.
we can alter cluster also. Let me show you here. Same example we have discussed. See this one, this is for the creating a cluster, right? See this one, if you want to alter already, so but the performance is degrading, we understand the clusters is not available, then what you can do is say this alter table,
Okay.
table 1 cluster by C1 and C2 specific columns we can able to give.
Okay.
Good. Any other questions? Okay guys, if you don't have, we will wind up and we'll connect tomorrow. Thank you all. Bye. Have a great day. Bye.